Hey, this is Mr. Barr, and let's take some notes on exponent rules multiplication. So get your notes ready to go. Get out a pencil and whatever else you're going to need. So, exponent rules multiplication. Our goal is I can work with positive and negative exponents. Why? This is the tool I'll need to have in high school. Multiplication is a great skill to have. I have 5 elephants and each one weighs 12,000 pounds. What is the total weight? Well, that's 5 times 12,000. Now let's ramp it up. Our sun, a star, weighs 2 times 10 to the 30th kilograms. And imagine that there are 4 times 10 to the third suns. What's the total weight? Seems far-fetched, but astronomers do this, and this is an example of where multiplication of exponents is useful. So by the end of this, we'll be able to multiply these two numbers. All right, let's get going on the notes. So we're going to start with our name and our title. So name. And the title is Exponent Rules Multiplication. Multiplication. And we're going to start with this one right here. I'm going to explain how this works, and then I'll give you a nice little rule for it. So we're going to start with x squared times x to the third. All right? And what is that? What is x squared times x to the third? Well, let's start with what is x squared? X squared is x times x, right? And x to the third is x times x times x. Yes? So what is this? If this is x times x times x times x times x, that is x to the fifth. There we go. We just multiplied it. So x squared times x to the third is x to the fifth. And we can see that right here in our notes. There it is. So the rule I'm going to give you is it's called base add. So when we're multiplying two bases with the same exponents, so base add. And what does this mean? It means, hey, add the exponents. When you're multiplying, so add the exponents. When we're multiplying, we add the exponents. When we are multiplying, we add the exponents. So right here, this would be, you don't have to put this in your notes, but this would be, where's my, see if this works. There it is, good. So this would be x to the, what's 2 plus 3? So it'd be x to the fifth. And what's 2 plus 4? That'd be y to the sixth. And what's 5 plus 5? This would be m to the 10th. Base add. And that is the exact same slide again. Okay, we're going to put this one into our notes. So how about this? If we had x times x to the second equals, well, the exponent there is 2, and the exponent right here is 1. There's a 1 right there. So this would be 1 plus 2, which is 3. This is x to the third. which makes sense. This is x times x times x, x to the third. How about this one? Y to the second times y to the fourth times y to the, what is this? Y to the first. We don't normally write the first, but we know it's there. So this is 2 plus 4 plus 1, which means it's y to the 7th. And this one right here, ooh, we're not going to freak out with negatives, are we? This would be m to the, let's draw this. What's 8? I add the exponents. 8 plus negative 5 is 3. M to the third. Monkeys play with monkeys, cats play with cats, x's play with x's, and y's play with y's. Integers play with integers. What does this mean? Well, it's going to set us up for problems like this. I call these Twix problems because they're actually 3 problems in one. Let's get this into our notes. So I have 4 x squared y to the 5th, and I have 3 x to the 3rd y to the 2nd. So the integers, the 3 and the 4 are going to play together. Integers play with the integers. The x's are going to play together, x's with x's, and the y's are going to play together, y's with y's. So we're going to do each of those little pieces. So we'll start with 3 times 4. 3 times 4 is 12. X squared times x to the 3rd equals x to the 5th. And y to the 5th, y to the 2nd, equals y to the 7th. So our final answer is 12x to the 5th, y to the 7th. So let's do some other ones. So right here, I have a negative 4 and a 6. That's going to become a negative 24. And I have an x and an x to the 4th. That's going to become an x to the 5th. And I have a y and a y to the 4th. That's going to become a y to the 5th. That one's done. This one down here, I have a 4 times a 6. That is a 24 again. I have an m to the negative 5 and an m. So this is a negative 5 plus 1. Negative 5, so it's an m to the negative 4. And I have an n to the 8th times nothing, so it's an n to the 8th. Now this one, you see that ticket right there? I could actually use up the ticket, and I could simplify this even more. This would be 24 n to the 8th over m to the 4th. Notice how I used that ticket to take it down into the bottom. And that is my last slide. Hey, thanks for watching. Have a great day.